Hello everyone, thank you for joining me today in this session. So today in this session we'll be talking about the C project static libraries. So firstly we need to understand what a static library is. A static library is simply a type of library that contains compiled code and data that can be used by programs at compile time or runtime. Okay, so it is called static library because, or let me say it is called static because the code and data it provides are linked directly into the program, becoming part of that particular program. So an example of a static library is simply, or before that, let's say functions that are included inside a static library. You know, whenever we use printf or putchar or put any standard function, right? So it becomes part of our program, and even though we are not the ones who wrote those functions, right? But whenever we use them, they become part of our program. So those functions we used are contained inside a static library. That's why we are able to have access to it and use it in our code. And whenever we use it in our code, it becomes part of our code. Do you understand? So these are what static libraries. Do you get this? I'm just giving you an overview of what a static library is. So this static library contains code. Do you get it? Compiled code and data that can be used by programs. That's why I give you an example with printf, putchar, strlen, a lot of these functions. So these functions are what are under a static library. So we can use them, and when we use them in our code, they become part of our code. So here in this task here, we are going to create our own static libraries. That's just what this task wants us to do. We are going to create our own libraries because we've been writing our functions ourselves, right? We've been writing functions ourselves. So even though we are just writing function that works exactly like that of the standard library, but a bit different, right? So now we are going to create a static library for all those functions we've been creating on pointer project, on the function project, and a lot of them. Okay, we are just going to see that. That's just what a static library in brief is. So before we continue, let me quickly pass this information. For those interested in our C mentorship program, the course application for the 7th batch is currently open. So kindly go to b12learn.com.ng, which is our newly launched learning management system, and then go to courses. Under courses, you'll be able to see ALX Complete C Programming course. So because I'm already logged in, that's why I'm saying continue learning here. In your own case, you will see start learning. Okay, so if I click on continue learning now, so as you can see, I have the project here. These are the first ones created: how to clear repositories, hello world, how to install Betty, all this. These are all the ALX project. As you can see here, we have them on this website. Okay, so for instance, if I want to access the small functions, small nested loops, I will just click on this, and as you can see, all the materials are here. Okay, so here as well, if I want to access functions and nested loops, all the course materials are here. So if you're really interested in taking part in this mentorship program, kindly message me using the WhatsApp link in the description of this video, and then I will share a coupon code which will give you a 30% discount on this course. Believe me, this course is very affordable. Okay, also if you have a course that you want to sell on this website, you can register as an instructor. Simply come here and then you can click on instructor registration. You can register as an instructor because I've already registered. That's why you're seeing you are not registered as an instructor. In your own case, you'll see a registration form which you need to fill. Okay, so after filling the registration form and after uploading your course, the course will be reviewed, and once everything is fine, we are going to make it available for others to have access to. Okay, so if there is any inquiry you want about being an instructor or enrolling in the C programming course, kindly message me, like I said, using the WhatsApp link in the description of this video, and I will answer your question, and also I will share the coupon code that you need to get 30% discount on our mentorship program. So thank you very much, and let's continue. Okay, so now this is what this, when you click on this file here, it's going to open this. This is what it's just giving you a guide on how to create your own static library, right? So one thing we need to understand is that for us to create a static library, we need to compile our files into what? Into an object file. Do you get it? So before that, let's go back here, or let's just explain this. Before that, I'll come back to that. Sorry. So one thing we need to do here is These are what? These are files. When you look at these, they are all .c file here, .c file. And these files here, when you look at them, they are function files. They have their what? Function. Functions are written inside these files, right? So here, they are being compiled. So as you can see, this -c simply means what? Is a GCC flag that means what? Don't link, right? So it's only going to stop after generating the object file, which is .o files, right? So this is what a wildcard saying that I want to compile all files that end with .c, right? So after the compilation, as you can see, when the list of the files in the directory is listed, as you can see, we are having .o, right? All the files with .c are also having .o. So now we've created an object file. So now that we have the object file, we can create a static library, right? Because static libraries are made from the object file, not from the C file. Do you get it? So for you to create a static library, you definitely need to compile first and generate an object code, right? So now after generating, after compilation, we are going to enter this command here. This AR here, the first argument here, it simply means archiver. Okay, it is used to what? To create the static library. So this dash RC here simply means replace or create. So this is just saying that if this static library here, this is the name of the static library in which you want to create. If this static library I want to create now, if it exists, then this R here is going to replace it. If it doesn't exist, this C here is going to create it. That's why it's important to use the dash RC for create and replace. Okay, so as you can see here, we have what? The static library name, and it ends with a .a extension. It means archiver. So whenever you see this .a, it means what? It is a static library. Okay, so and what? This is a wildcard that I'm targeting all .o. So this just said, so this is just saying that all .o files, I want to use them and create a static library called this. Do you get it? So this AR again is being called, but in this case a different flag is used, which is .t. So this .t here is used to list the content of your archiver. So this is what you have inside your static library here. 00.o.o. These are all the .o files inside your static libraries. So the next thing you need to do is you need to run this command here, run lib. You pass in the static library name. So what this run lib does is simply indexing. What I mean by indexing is that it's kind of arranged the functions or the object. Do you get it? For easy access, whenever the need of a function arises, it knows where to just go and locate that particular object. It's just like you looking for what shall I say? Let's say you have a textbook and you're trying to look for a certain topic in the textbook. So you go to table of content, right? You just go to table of content and you look for the page where that particular topic you are searching for is, then you just go to the page. So as you can see, it makes things easier for you. So assuming the table of content is not present, how do you think you can be able to get the topic you want? Let's say in a textbook that has let's say 100 pages. So you have to flip through all, right? So as you can see, the table of content helps in reducing the time, right, to look for a particular topic. So that's exactly what runlib does here. Okay, so it's going to index all the object here, so that if the need for each for any of it arise, it knows where to go and look for it. Okay, so that's simply what this is, right? These are just the commands you need to know to create your own static library. All right, so let's move on. So please go through these materials here. I've already explained AR, I've explained runlib. So this NM here is used to examine the symbol table of an object file or a library. So the symbol table simply contains information about the symbols defined or referenced in the file, such as functions, variables, or other entities. Okay, other named entities. We are going to see that as well. Okay, so here, what we need to do first here to solve this problem here is, as you can see, they said create the static library libmy.a containing all the functions listed below. So these are function prototypes, and all these function prototypes here, we've written these functions ourselves. These are prototypes from functions and also from pointers. So we've written all these prototypes ourselves. Believe me, we've written them. Okay, so we are going to what? We are going to use this particular prototype here. So if it says if you haven't coded all of the above functions, create an empty ones with the right prototype. So don't forget to push your main file to your repository, it should at least contain all prototypes of the above functions. So this is simply saying that if you don't have these functions here coded, you can just create an empty function, but make sure that the prototype is the same as this one here. Okay, so now what we're going to do here is this. These are the prototypes, right? I've already coded them, right? We have some of them in what functions, some of them in 0x05 pointers, arrays, and strings, some of them in 0x06, some of them in 0x07, right? So I'm going to copy them from those different folders in which they are initially to what? To my static libraries here. Okay, so as you can see, this is the file in which, the directory in which we are going to do this work, 0x09 C static libraries. Okay, so what I'm going to do here is, let me refer to my ALX low level programming. So first I need to look for putchar is lower is alpha, right? ABS int is upper is digit. Let me just look for them one by one. I just want to show you the shortcut to do this. Okay, if you don't want to be typing one by one, since we've already wrote the function, we can just copy them. So the first one I'm going into, let me just list my, okay, let me go into 0x02 functions. 0x02 functions. All right, so let me list the content. So here I'm looking for putchar. I already have putchar, right? So I will just say cp means copy, right? Cp means copy here. So cp, what am I copying? Putchar.c, right? So putchar.c, it is one of the functions in which I need, right? And then what again is lower.c. So where is lower? Yeah, so as you can see, we have is lower here. So I'm also copying this, so I'll just type in 3 is lower.c, and then after is lower, we need to check for is alpha. So we are targeting is alpha. Where is it? Is alpha? Yeah, 4 here is called is alpha. Yes, then what again? Underscore abs. Are we having abs anyway? Yeah, this is it, 6.c, right? So I just say 6 abs.c. I think that's the code, right? Okay, then what again is upper? Do we have is upper here? Yeah, so I think we don't have is upper here. So now I'm done copying all the functions I need from 0x02 functions nested loop, right? So I'm going to take them where I need to what? Pass in this ... It means that I want to copy these files but exit out of this current directory, right, which is 0x02, then slash. So now I will pass in the name of the directory in which I want to copy them to, static libraries, right? So I'll just press enter. So they are now copied into static libraries, and we are going to see that. So the next thing we need to do here is we need to check for what is digit. I think this should be in 0x04. So I need to exit this as well. So I just type in 0x04. Yeah. So I'm copying what is digit. So I just say cp, where is digit here? This is digit, right? So I just pass in 1 is digit.c. Yes, then what again do I need? Do I need anything here? I think that's all. I only need is digit in this case, right? So I will just say what? I will just say ... which means move out of this current directory and go into 0x09. So it's going to copy it to that directory. So the next thing is we have puts. So this is definitely in pointers. So I have to exit this and go to what? 0x05 pointers, right? That's the first project on pointers. So let me list it. So here we have puts. So I will just say cp. Wait, which one is puts? That is underscore puts. I think it's somewhere. Let's look. Yeah, 3, right? 3 puts.c, right? So we are done with this part. So the next thing is strcpy. I think it is, yeah, this is it, 9, right? So I just say 9 strcpy.c. Take note, I'm copying the .c files. So which one again? A to I. Do I have? Yeah, this is A to I. 100 A to I.c. Then which one again? We have strcat. Let's see if strcat is here. Okay, I think strcat is not here. Yeah, so I think strcat is not here. So I'm done copying what I need from 0x05 pointers. As you can see, I'm copying the functions. I just want to ensure that I have the functions here listed, all of it. Okay, so now then what? I'll just say ... move out of this directory and paste it in what? Static libraries. Enter. So it has been copied and pasted there. So the next repository I need to check or directory is what? That of 0x06. pointers, arrays, and strings, right? So let me list them also. So let me see, I'm looking for strcat, right? Where is strcat? Yeah, as you can see, it is here. So I'll just say cp here 0 strcat dot c. I'm done with this part here. Then the next one is strncat. Yeah, that is one here. Did you see it? strncat. So strncat dot c. Then which one again? strncpy. Where is it? Where is strn? I believe it's here. Well, I can't see it, so I don't think it's here. I think it's, no, it has to be here. strncpy. I think I can't see. Okay, yeah, this is it, 2 here. 2 strncpy.c. And then which one again? We have strcmp. Where is it? Yeah, this is it, strcmp, which is 3 strcmp.c. So which one again? Memset? No, memset is not here. Memset is in 0x07. So these are the only functions I need in 0x06, right? So I will copy them to my static library folder. So it's going to be dot dot, move out of this directory and go to 0x09. So take it there and paste it, right? So I'm done with this. So I'll exit out of this as well. So the next one I need to go to is 0x07, right? Which is the last directory for pointers. So ls. Okay, so I will say cp. I want to copy memset, which is task 0, right? Memset. So I just say 0 memset.c. Right, I'm done with one. Then memcpy. Where is memcpy? This is it, 1. Task 1 memcpy.c. And then after that we have strchr. Where is strchr? Yeah, this is it, task 2 here. So 2 strchr.c. Then we have what? strspn. This is strspn, right? So it's going to be 3 strspn.c. And then what again? We have strpbrk. Where is it? This is it, task 4, right? So strpbrk.c. And then what is the last one? strstr. This is it, 5. So I just say 5 strstr.c. So I'm done, right? So I just need to what? Pass this, and then what? 0x09. Yeah, so I've copied it. So let me exit out of this and let me go back to my 0x09 static library. All right, so let me list the content. So did you see that I now have all the functions copied? So let's count how many functions are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So let's count how many do we have here. 1, 2, 3, 4, 5. 5 times 3 is 15. And then what? 16, 17, 18. Okay, we are having 18 of it here. So I think there are some in which we are missing. Let me just look at it. I can see we have putka. After putka, we have isloa. Where is isloa? Let's just check. This is isloa. Is alpha. Where is alpha? So as you can see, we don't have is alpha here. So it means that I've skipped is alpha. So let me just go back. Or before that, let's check which one again is it we don't have. Remain 1. So ABS, this is ABS, we have it. Then is upper. Where is upper? Is upper? So definitely we don't have is upper as well. So we are going to copy is lower and also is upper. So let's go back. So I think this should be in 0x04, right? I guess. So ls, we're looking for is upper, right? And also is alpha. Is upper, yeah, this is upper here. CP. So this is task 0 is upper dot c, right? So I'm taking it to where? To 0x09 static libraries, right? So I think the next one, which is alpha, is not here. So we need to go out of this and go to 0x02 functions nested loops. So I think it should be here. That of is lower, right? Sorry, is alpha. Where is it? Is alpha. Is alpha. Is alpha. Yeah, this is the task 4. So CP4 is alpha, right? So I've copied it. Or let me say I'm trying to copy it, then this, and then the location, which is 0x09 static library. So I think this should be all now. So let me go back to the repository, sorry, the directory. So wow, so we are still missing one again, because I can see here is 19. So I think, which one are we using? Let's check. Is strlen here? strlen is not here, so we need to copy it as well. So this is a pointer. It is in what I believe this is in the first pointer. So 0 by 0 5, right? Pointers, arrays, and strings. So let's see. That is strlen. Let's look for it here. This is it, task 2. Okay, so cp, so cp2 strlen. Please, you need to ensure that you have all these files. That's why I'm trying as much as possible to see all these files are inside that directory. You need to ensure you have it. If not, your checker will fail. You'll not be able to get the exact content you want. Okay, so I'm taking it to my 0 by 09, this. All right, so let's go back. 0 by 09, sorry. So let me list it. So I believe now I should have 23, 6, 9, 12, 15, 18, 19, 20. Yes, so now we have 20 functions here. So all these prototypes here, we have their functions here. So the next thing we need to do is to create the main file, the main.h file for this, right? So let me copy. So I just say main.h, right? So how do we do? We first need to what? Define it, sorry, guard it main_h, and then hash define. This should not be in caps. Hash define main_h, right? Then hash endif. All right, so if you can remember, in our main.h we've been using, there are functions that they are not available here, right? So these functions, we need to include what? The stdio.h for us to use them. Just like the null we've been using, null, right? So we need to add stdio.h here in our header file. Else it will give you an error during compilation. So hash include, yeah, so stdio.h. Also, if you can remember, there is somewhere in my codes, the codes we'll be writing on functions, where I used what? This strlen of the standard library to solve a problem. Instead of writing our own, I said I'm just going to use that of the standard library, and I'm sure the checker will pass, right? So now I need to include the standard library or the header file for that particular strlen.h. So include this. So now we have our header file set. So now the next thing we need to do is to begin creating our static libraries. So let's refer to this. This is the guide here. So the first thing we need to do is to compile, and I've explained why we need to compile, right? We said this -c here is simply saying that compile but stop before the linking stage. That it will generate the .o files, which is the object file, and it will stop there. It will not link. So this is saying that I want you to compile all .c files that end with what? .c extension. So as you can see here, our .h will not be included. So if I press enter, now I've compiled it, right? So let's move to the next step. The next step is to create the static library now, right? From our question here, we are told that the static library name should be what? libmy.a, right? So I just say I've explained this, -rc, I've explained this as well. This means replace if it exists, if it doesn't, create it. So libmy.a, right? This is what? The library name. So we will now what? Say I want to what? Or before that, let me show you something. ls. Did you see that now we have .o files? All .c files here have their own corresponding .o files. So now we've created what? .o files. Do you get it? We've created .o files. Just look at this here. They have their own here as well, right? So now the next thing we need to do is to create the static library. So we are going to create it from what? From the .o file. So the static library name should be libmy.a, and it should what? Target .o files. Do you get it? Just look at the command here, right? So I'll just press enter. So now it has been created. So now let's list what we have inside our static library now. It's simply ar -t, then libmy.a. I've explained the what? The -t flag, I can remember. So these are what? The .o files we have. These are all the functions we have in our static library, right? So the next thing we need to do is what? Is to index it. That's why we use what? Rallib. So I'll just say rallib. What is my library name? libmy.a. Isn't it? Press enter. So I'm done creating my own static libraries now. So this is the last step. Do you get it? So here I've already explained what nm does, right? It is used to examine the symbol table of an object file, right? So if I should copy this now, it's just used for examination, to examine it. So as you can see, these are all the functions we have. It's just used to display a few details about it. So as you can see, we have the same thing here. Did you see that we have the same thing here? All right, so the next thing we need to do is to copy this test file here. As you can see, they have main.c file. So I'm going to copy this. So I'll create what? My main.c file. Sorry, main.c, right? So I will now copy it. Mind you, this main.c file is the last file you need to create, and you need to create it after creating the static library. Okay, so now the next thing is copy the compilation command here. So, and paste. All right, so we are done. So let's run the file. This is that is this with dash code something. So as you can see, we are getting the exact output. At the end of the day, my goal is something at the end of the day, so this is what, this is how to create a static library. So we've successfully created a static library. That's also what this question is asking us to do. I believe this is clear, right? So these are all the files we just need to create. We just need to create libmy.a and main.h, right? We created those functions because we don't have them, right? So don't forget to add, commit, and push to your GitHub, and then you can run your checks. So let's move on to this task. So this task here says we should create a script called this. Let me just open it first. This should be the name of the script. Oops, vi. So it's going to be vi this, right? So that create a static library called this. The static library it will create should be called this from all the .c files that are in the current directory. All right, so what I need to do here is, how do we create script? Hash exclamation mark, right? bin/bash. I'm sure you guys did not forget this, right? So what's the first thing we do when we're trying to create a static library? We first compile, right? So I'll copy the compilation command here. I'll just copy this and paste here. That's the first thing we need to do. We need to compile all .c files into what? Object code. Right? So after that, what is the next thing we need to do when creating a static library? We need to now pass the command, right? So I'll copy this and I'll paste this here. So I'll pass in the name that we're asked to create, which is this liball.a, right? So I'll pass liball.a and I'll pass asterisk.o. So I want to create a static library called liball.a, and I want to include all the .o files here. Do you get it? That's also what this means. So press enter again. Then what's the next thing we need to do? Or let me say the last thing. The last thing we need to do is simply to run lib, right? All this part here, they are not necessary. This is just used to list it. But to create it, we just need these three commands: compilation, ar, lib. That's all. Okay, so here I will just say lib. What's the file name? liball.c. Sorry, .a. That's all. Right? So this is simply the script. Firstly, it compiles. Then after compiling and generated the object code, then we what? We create the library and then we index it. That's all. So you simply just escape this. Maybe there is need for it to convert to executable, so it's simply going to be u plus x. And then what's the file name? Create this. I think that's all. Alright, so let's test this. Let me copy. So as you can see, these are all the C files we have. They are just displaying all the C files here, isn't it? So now let's open the file here. This is the script in which we created, right? So let's run the script. So we are running the script. So we've run the script. So I'm expecting this script to create this library now, because I've already run the script, right? So I should have liball.a created, isn't it? So now let me list all the files that I have with .a. So let me copy this. That way I'll be able to see if the library has been created. So as you can see, I have liball here. This libmy is from the previous task, and this liball.a is the one in which we are told to write a function that will create it. And it means that, sorry, a script that will create it. And we created the script and we run the script. So that's why it is created. So it means our script is working the way it's supposed to work. Do you get it? So let's copy this as well. Let's just see all the object code inside it. So did you see that? These are all the object code inside. So it means our function or our library has been created. So don't forget to add, commit, and push to GitHub and run your checks. So thank you very much. This is the end of this project on static libraries. Till we meet in our next video.